Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 10.4, Day 1, solving quadratic equations by factoring. So let's look at the following two graphs. What are the solutions to the equations? The solutions are where we cross the x-axis. So in the first graph, our solutions are at these 2 points. What those points are negative 3, 0, and negative 1, 0. In the second graph, our solutions are here and here. Those points are negative 2, 0, and 4, 0. Okay? Now, if we go ahead and factor these exact same equations, what we're going to find out is that my factors would be x plus 3, x plus 1, and x minus 4, x plus 2. All right. So what do you notice about the solutions to the equations using the graphs, so where it crosses the x-axis, and the factors of the quadratics? Well, if you just look at the numbers, I have 3 as a factor and negative 3 is my solution. What we're going to find out is that they are opposites from where the graph crosses the x-axis. So in other words, the factors of the quadratic polynomials are just the opposites, or just the opposite of the solutions to the quadratic equations. All right. If we let y equal 0 in the quadratic equation, we are able to solve for x using one arithmetic fact, the zero property, the zero product property. What could we fill in the blanks with in the following equations to make them true? Well, if you look at the second one, 5 times what would get me 0? Well, that's 0. What times 2 gets me 0? That's 0. Also, 0 times 0 can get me 0, right? So the zero product property, here it just says the zero property, states that if two quantities multiply to be 0, then one or both of them must be 0. So mathematically, if a times b equals 0, then a equals 0, or b equals 0, or a and b equals 0. A and b would equal 0, okay? Remember, the solutions to quadratic equations on the graph are where the parabola crosses the x-axis. The parabola is just a fancy name for the graph. This is also where y equals 0. So we can let y be 0 and use the zero product property to solve for x. How we're going to do that is we're going to keep 0 out front. Well, I actually want to put 0 behind. When I usually do this, I'm going to go ahead and factor this. So I would get x plus 2 times x plus 3, and then I'll set that equal to 0. So I kind of flipped my original equation a little bit. From here, because x plus 2 is multiplied by x plus 3, if we look back at the zero property, either one of the two must be 0, and at the same time, both of them could be 0. So what we're going to do is, in order to solve for x, is we're just going to then set each one of these equal to 0, and solve. So to solve the first one, x plus 2 equals 0, I would have to subtract 2 from both sides. So x would equal negative 2. To solve x plus 3 equals 0, I'd have to subtract 3 from both sides. So x would equal negative 3. All right. Let's go ahead and move on. Imagine we have already factored a quadratic equation. Using the following equations, or solve the following equations using the zero property. So in this case, I've already factored it, so all I have to do at this point is set each factor equal to 0. So I would subtract 5 here. X would equal negative 5. 2x minus 6 equals 0, so I would add 6. 2x would equal 6. Divide by 2. So x would equal 3. Those are both answers to our equation. Okay. On to problem number 2, I'm going to take 3x minus 5, set it equal to 0. If I add 5, I end up with 3x equals 5. Divide by 3. So x would equal 5 over 3. I also have to set x plus 2 equal to 0, subtract 2, and x would equal negative 2. When you're working through these problems, some of them like x plus 5, you'll know that x is going to be equal to negative 5. But because it's telling us to use the 0 property, I do have to set each factor equal to 0. In problem 3, I do not have two factors that are in parentheses. However, my first factor is going to be this 3x. So I'll set the 3x equal to 0. If I divide by 3, I end up with x equals 0. 2x minus 100 will also be set equal to 0. Have to add 100. So 2x equals 100. Divide by 2. So x would equal 50. Okay? Moving on. Factor and then solve using the 0 property. So the last unit, or the last note sheet that we went through, the last section we went over, we would have used square roots here. But in this case, it's telling us to factor and then solve using the 0 property. So what I'm going to have to do is factor this using the difference of two squares. So I'll have x and x. I'll have 6 and 6. One needs to be positive, one needs to be negative. At this point, I'll set them each equal to 0. So if I subtract 6, x would equal negative 6. X minus 6 equals 0. Add 6. X would equal positive 6. If I were to put either negative 6 or positive 6 back in for x, x squared or negative 6 squared would get me 36. 36 minus 36 would be 0. 6 squared is 36. 36 minus 36 would get me 0, which means that both of those answers would satisfy our equation, and we would be good. Okay? On to problem 5. Remember, I like to put the 0 behind instead of in front. You can kind of do it whichever way you like, though. So to factor this, I would get x plus 4 times x plus 2 is equal to 0. Set x plus 4 equal to 0. So subtract 4 from both sides. X would equal negative 4. X plus 2 equals 0. Subtract 2 from both sides. So x would equal negative 2. On to problem 6. Remember, guys, I told you that factoring is never going to go away. You need to know how to do difference of two squares. You need to know how to do generic factoring. You also need to remember GCF. In this case, my GCF would be 2. It'd leave me with x squared plus 7x minus 30. Bring down my 2 sets of parentheses. From x squared, I would have x and x. Now, what can multiply to 30 and add to 7? I could have a positive 10 and a negative 3. I'm going to set everything equal to 0, even this 2. But once you see that 2 is it's not equal to 0, right? I can go ahead and cross that out. But x plus 10 is equal to 0. Subtract 10. X would equal negative 10. X minus 3 equals 0. Add 3. So x would equal 3. Okay? On to problem 7. Again, I have a GCF. If I take out a 6x, well, 6x squared divided by 6x would be x. 12x divided by 6x would be 2. Set that equal to 0. So 6x equals 0 divided by 6. X equals 0. X plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. Okay. On to problem 8. Again, I have a GCF of 3. Leave me with x squared minus 2x plus 1 is equal to 0. To factor this, I need to keep my GCF, 2 sets of parentheses. X would go in the front. Negative 1 would go in the back of each. Now here, because both of my factors are negative 1, I'm going to set 3 equal to 0, which is not true. I only have to solve this one time because both of my factors are the same. So if I add 1, x would equal 1. Okay? I wouldn't have to do that again because it's just going to get me the exact same answer. The last problem, problem 9. If I factor this, I'm going to end up with x minus 12 times x plus 4 is equal to 0. Set x minus 12 equal to 0. Add 12. Add 12. X equals 12. X plus 4 equals 0. Subtract 4 from both sides. So x equals negative 4. To summarize your learning, How are the solutions to a quadratic as seen on the graph related to the factors of the quadratic equation? Simply put, they are opposites. When is the zero property, or what is the zero property, and how does it help us solve quadratic equations? That is if two numbers, terms, factors, whatever you want to say, multiply to 0, then one or both must equal 0. That is what the zero property is. How does it help us solve a quadratic equation? If y equals 0, we can then solve for x by setting the factors equal to 0. Well, that is the end of our lesson. Make sure that if you have any questions, you come in and see me. If you are still struggling with factoring, you really need to come in and see me. Otherwise, thank you very much for watching the video, and have a great day.